Yeah, today we're going to talk about percentiles, and this is a topic that extends the notion of the median we talked about before. Remember, the median is the value of a data set that separates the data into two equal parts. So it's a measure of location, and here is percentiles. So usually we want to use percentiles when our as well as the media when our data is badly skewed. So we're gonna start with a data set where the values of it are x1, x2 up to xn, and then we want to arrange this order in arrange this data in increasing order. So our smallest value is x1, our largest value is xn. I'm going to define the pth percentile. That p is a number between 0 and 100 as the number x, such that p% of the measurements are below that value and the rest are above it. So if we take p to be 50, that means the 50th percentile is the value where 50% of the data below it and 50% of the data is above it, which we already know that to be the median. Of course, there are three values that are of particular interest to us, and which are the 50th percentile, which is the median, the 25th percentile, which is called also the first quartile, and the 75th percentile, which is the third quartile. But while we are evaluating this, we can evaluate any percentile, like the 30th percentile. And so I'm going to give you examples for each one of these and describe a general one method how to evaluate all of them, and other ones can be evaluated similarly. So if I have this data set 2, 5, 8, 10, 11, 14, 17, and 20, and if you notice that the numbers are already arranged in ascending order for me, so I want to find the 30th percentile, and I want to do it in two steps. First, I want to find the location of the percentile in this data. Where is that location? And then I'll multiply, because I'm using 30th percentile, I use 0.3, what is that connection here, and multiply that by n plus 1. N is the number of measurements, so n is, if I count here, 1, 2, 3, 4, 5, 6, 7, 8. So 8 plus 1 is 9. So I have 0.3 times 9, and that's equal to 2.7. So what this number tells me is that my percentile is between the second and the third value. So the 30th percentile is somewhere between 5 and 8, but where between 5 and 8? That's the question, and that's where the second digit tells me it's 70% the distance between the second and the third. So I have to go 70% of the distance between the two, which is, the distance is 8 minus 5, so that's 70% of the difference, which is 3. And that's where I get my 30th percentile, which is 5 plus the 70% of 8 minus 5. And so that gives me a value of 7.1. Let's apply this to the first quartile, or the lower quartile, or the 25th percentile. So first, 0.25 times n plus 1, that's 0.25 times 9, or 2.25. So now I know immediately my first quartile is between the second and the third, but now it's 25% of the distance between the second and the third measurement. So it's the second measurement is 5 plus this point this 2.5 goes here, and the difference between the second and the third is 8 minus 5. So I do the calculations, I get 5.75. The median, we know the median, so if I have 7 measurements, and I know very well that the median is, sorry, I have 8 measurements, so the median is the middle 2 numbers, the average of the middle 2 numbers, which is 10.5. So we already knew that before then. So let's see how this method works. So I get median is 50th percentile, so that's my 0.5 here. The n plus 1 is 9, gives me 4.5. So the median is between the 4th and the 5th measurement. So it's between 10 and 11, and it's half the way between 10th and 11. So it's 10 plus 0.5, 11 minus 10, which is 10.5. Do that one more time for the 75th percentile, and we should probably pause here and make sure you can do this by yourself. Okay, so first we get 0.75 times n plus 1, 0.75 times 9, 6.75. So now my third quartile is between the 6th and the 7th measurement. 1, 2, 3, 4, 5, 6. So it's between 14 and 17, and I want to go 3/4 of the distance between 17 and 14. So it's 14 plus 0.7, 17 minus 14, or 16.25. Good. A few other things you can do. So now we got all these measurements. So if I take the third quartile, we're going to use, of course, Q3, if you noticed, for third quartile, Q2 for the second quartile or the median, and Q1 for the first quartile. So if I take Q3 minus Q1, that's called IQ, the interquartile range, which is really, this is where the middle 50% of the data falls, is between these two values. Sometimes we use quartiles to create a box plot by identifying the inner and outer fences as follows. So if I take the inner fences, would be take Q1 and take negative 1.5 IQ or IQR, and Q3 plus 1.5 IQR. The outer fences, I just go 3 IQRs below the first quartile, and I go 3 IQs above the third quartile. And typically what I should, so if I do that, what I should expect is about 5% of the measurements will fall beyond the inner fences, and measurements that fall outside the outer fences are called outliers. So here's an example of graphing the data, some data where we have, this would be our median, this would be our first quartile, our third quartile, and then these are called the whiskers of the graph. Don't want to say much. Okay, now we go to some of the comments. So we have to remember that with that graph we've seen 5% of the measurement should fall beyond the inner fences. Measurements that fall outside the outer fences are called outliers. Remember, with the empirical rule, we were able to summarize the data if it's bell-shaped using the mean and going to each side 1 standard deviation, 2 standard deviations, and 3 standard deviations, which gave us 6 classes. If the data is skewed, that's not going to work. So the way we can summarize data is by using something called the 5-number summary, and that's basically we pick the minimum value the first quartile, the median, third quartile, and the maximum value. So as a homework assignment, you should find the interquartile range, the inner and outer fences in this above example as practice. Let me give you another graph where you can show the inner fences and outer fences. So here is an example where we have skewed data. You can see the data is skewed to the right. It's not that well shaped. So if we want to summarize this data, I would just pick the median, which would be here. The quartile is first quartile is here, third quartile is here, and this is my minimum and largest values. And you see those intervals are not equal, so they're different because they are just picked so that there are 20 quarter of the data is in each one of them. And you can see here that each one of these intervals contains 25% of the measurement. So that's an alternate way of summarizing data. And that's the end of this topic.